I'm Virginia Sawyer. I'm a third-year PhD student at the University of Maryland, College Park, and I've been working on planetary boundary layer detection algorithms for aerosol lidar. And the idea is that because most aerosol pollution is emitted close to the surface, and because the boundary layer is a buoyantly stable inversion that the aerosol can't mix upward through, if you know the vertical distribution of aerosol, then the point where it drops off from a fairly high concentration close to the surface to a lower concentration aloft is probably the boundary layer. And there are two algorithms that are fairly widely used to find that point. One of them is the Haar-Wavelet covariance transform, and it takes this step function and compares it to the backscatter profile, and wherever there's a big step in the data, it will increase. The maximum of the wavelet covariance transform is the boundary layer. And that works great if you don't know much about the atmospheric conditions that you're starting with. So it's good for an automated process where you can have many sites over long periods of time. There's a second algorithm that may actually be more accurate, but the better your first guess is, the better the final result will be. This is from Stein et al. 1999, and it's an iterative curve fitting process. So what I did was I ran the Haar-Wavelet covariance transform to find a first guess of the PBL height, and then I entered that in to the iterative curve fitting process to find a more refined value. And then I compared it to radiosonde values for the same sites. I had Isolot, which was in the Arctic Ocean, a fairly short-term campaign, and 8 years of data from the SGP site in Oklahoma. And the results are very noisy. I'm getting R-squared values around 50%. And partly that's because there's a lot of uncertainty in both the radiosonde PBL detection and the LiDAR PBL detection. Partly it's because all the different atmospheric conditions that could affect it and could affect the ease of detecting the boundary layer are all mixed in together, so I can't tell just from the automated process whether there are multiple inversion layers or clouds in the way, or whether the boundary layer is very stable and deep and hard to pick out of the rest of the signal. But in the future, I'm hoping to look at different methods of radiosonde-derived PBL height detection and some other instruments and see if I can sort out those problems and improve a bit.